Thanks for that introduction. My name is Alex Hertel, and today I'm going to be talking about the world computer. So basically, my talk today is going to be about how to make sense of these emerging technologies that we all see. Just a little bit about myself. I'm the co-founder and CEO of a company called Xperiel. I completed my PhD in computer science and complexity theory at the University of Toronto. So if you're detecting a Canadian accent in my voice, that's where it comes from. Prior to that, I was a co-founder of a company called Walletto. And so that was a digital wallet that was acquired by Google, and that became Google Wallet. And to maybe frame the discussion today, it's helpful to look at an example from a different space. So if you look at music technology, like a long time ago, we had vinyl records. That was the first way to record music. And then the 8-track was invented. And then the next generation was cassette tapes. And then we went optical and we had compact discs. And then finally, we had digital music. And so it's really fair to ask two questions here. Like, one is, what comes next? And then the next question is, what comes last? And if you look at digital music, you know, it's hard even to imagine what could come next. It may well be that it's kind of in its end state and there's nowhere to go from here. And you always have to be careful when you make statements like this, because then 5 years down the road, someone invents something new and makes you look silly. But, you know, it's at least not an unreasonable hypothesis to be, or an unreasonable question to be asking. Okay, so let's bring that over into the computer realm. And we can look at the generations of computer technology in kind of the same way. Like originally we had mainframe computers that were filled whole rooms or whole buildings, and they were so big and expensive that only governments and universities and corporations could afford them. And they would run these corporate number crunching apps. And then next the PC was invented, and that democratized computing. And now in principle, anyone could have a computer in their home and they would run desktop applications. You know, and the next big platform shift was the World Wide Web, and this big global network was built, and the sort of the native format there was web pages that it delivered. And then more recently, we had the mobile revolution. And so we all now carry smartphones and have wearables, and the native format there is mobile apps or a mobile web hybrid. And so again, a fair question to ask is, what's going to come next and what's going to come last? And so here, you know, what we're seeing is a convergence of several technologies into what we call the world computer. And the world computer, it natively runs what we call spatial compute applications. So what do we mean by spatial computing? So the concept here really is one of mixing bits and atoms together. Like if you look at all of these previous technologies, basically what they were was they lived in cyberspace. You know, the web is built entirely out of bits and there's no atoms there. But spatial computing is about putting bits and atoms together. Like a good example of that is a company like Uber is an early good example of spatial computing, where you've got an app and you put in your data and you call a taxi to come and pick you up. but then a physical car comes and picks you up, right? And so that's, like I said, mixing those bits and the atoms together. And so what is the world computer? Well, so to make sense of this, it's useful to go back to this old parable of an elephant in the dark, right? So imagine there's 3 people and they're in a room, a dark room with an elephant, and they're trying to make sense of it. So one person touches the trunk and that guy thinks it's a snake. And the next person touches the elephant's leg, and to him, it feels like a tree. And then the final person grabs an elephant's tail, and to her, it feels like a rope. And none of these people are right, because they've only got this local view of what an elephant is. So it makes sense to take a step back and look at the bigger picture. So that rather than looking at the world from this sort of bottom-up point of view, you can look at the world from a top-down point of view, and you realize this is an elephant, and those were just the parts of the elephant. And when you do that, the world kind of makes more sense. And we can do exactly the same thing with the emerging spatial compute technologies that we're seeing. And in the same way that it doesn't make sense to look at the pieces of an elephant and try to make sense of that, I would argue that it also doesn't make sense to look at these emerging technologies and try to make sense of the world in that way, in this bottom-up kind of way, right? So everyone knows what the internet is, but we have all these other emerging technologies. So 5G and edge are often kind of lumped together. We have cloud computing, we have the Internet of Things, and we have wearables. And of course, This being AWE, we have AR and MR and XR. And again, you can look at all of these different technologies in isolation, just like we were doing with the parts of the elephant. But if you do that, it doesn't really help you. Instead, if you take a step back and if you look at the bigger picture, you realize that these are parts of something much bigger and something much greater. And this is what we call the world computer, and it's kind of the metaphorical elephant in the room. So let me describe that a little more. So if you look at a traditional computer, the kind of computer that used to sit on your desktop, it actually turns out that a computer is a network. Every computer out there is a network. I mean, you don't really usually think of it that way, but it's just a bunch of parts and a bunch of devices that are networked together, right? So you used to have this box sitting on your desktop, and that's where you have the RAM and the CPU and the hard drive and so on. Like those are the brains of the computer. And then you had all of these peripherals that you would plug into your computer, right? You have your camera and your keyboard and your mouse as input devices. And you'd have output devices like a monitor or a printer or speakers. Those are all networked together. And it's your USB cables and the Bluetooth and the Wi-Fi and the event bus in the computer itself that are acting as the glue that then connect all of this together. And then, of course, you have the software, right? You've got your operating system. You've got your programming languages like C++ and Java that you can use to write more software for your computer. And it's the same thing when you look at a smartphone, right? A smartphone is really just a computer in your pocket. It's less appropriate to call it a phone than it is to call it a computer. And it's exactly the same type of creature, right? You have the CPU and the RAM and the storage, and those are the brains of this computer. You have all these input devices. You have your touch screen. And here things get a little interesting because your smartphone has a lot of sensors in it that make it possible to interact with the physical world. So it has a GPS, it has camera, Bluetooth, microphone. These are all physical sensors. So a smartphone inherently can interact with the atoms in the physical world. And then you have your output devices as well. You have your speakers, your touch screen, you have your haptics when your phone vibrates. And then, again, make no mistake about it, this is a network. It doesn't seem like it because it's all housed in this beautiful form factor in your hand, but these are all just different devices that have been networked together. And again, you have your operating system, you have your development tools so that you can go and you can write the software on these platforms. Okay, so what does that have to do with the world computer? Well, we can see that the whole world is kind of becoming this giant computer, a computer just like the ones that I've been showing you with all the same parts. And the data centers around the world, those are replacing the brains. That's where, in the data centers and the edge servers, you've got computers with their hard drives and their CPUs and their memories. And that's playing the same role that the box on your desktop used to play. And we have all these input devices, these so-called peripherals, but they're in the form of the Internet of Things. So we have our doorbells, our thermostats, all of our wearables, our smartphones, our IoT devices. Those are playing the same role as the input devices like your mouse and your keyboard used to play. And we also have our output devices, right? There again, we have our smartphones. We have screens all over the place. We have IoT devices. And very importantly, this being AWE, you have your AR and your MR and your XR, and those are the pixels. Those are the screens and the monitors of the future. And then behind all of that, you have the network. You have the internet, and you can really view the internet as being basically an infinitely long extension cord that's connecting all of these pieces together. Now, there are still some parts missing, right? There is no operating system per se for this world-sized global computer, and there are no good dev tools. And actually, as a plug to my company, Xperiel, that's actually what we're working on, where we've been building exactly those, the operating systems and the dev tools for this world computer. But I won't go too much into that. So this is a von Neumann computer, just like your desktop PC, just like your smartphone, only on a monumental kind of Earth-sized scale where the data centers and the brains of your computer might be thousands of miles away. And with all of these technologies converging, that's what you get when the Internet of Things, when augmented reality, when the data centers, when 5G and edge and wearables come together, you get this world-sized computer. And it completely unifies the physical and digital realms. Whereas the older computers that I showed you, those were purely digital. They lived purely in cyberspace. They dealt with bits. But again, here with the world computer, we're merging the bits and the atoms together. So spatial computing is native to the world computer. And mixed reality will be its user interface, or at least one of the major user interfaces. So if you look at the world today, we've already got devices that are interacting with the Internet of Things. They're displaying mixed reality, but mostly it's all being done on smartphones today. And you're using sensor inputs, you're using the smartphone to control the Internet of Things directly. And you're able to use the sensors in the phone that we talked about to perform actions in the physical world, like vision recognition, audio recognition, like Shazam is another good example of a spatial computing app. Geofence entries or exit, NFC smart poster tabs. You can walk near beacons. Like, these are all physical sensor interactions and all those IoT devices that you can control. But where the world is going, and it's not going to take too long, is we're going to have our augmented reality wearables. And you're going to be walking down the sidewalk. And as my friend Charlie Fink likes to say, the whole world will be painted with data. And so you're going to be walking down the sidewalk. You're going to be interacting with the AR cloud through your AR glasses. And you're going to be able to control all of those devices, those IoT devices, through this new type of user interface called mixed reality. Because at the end of the day, that's what mixed reality and augmented reality are. It's a user interface. And so this world computer will have many input modalities. I'm not claiming that your smartphone is going to go away, but mixed reality will gain a larger prominence because it's just a very natural and native way to interact with spatial computing in this way. So going back to the idea of these different pieces and the different pieces of the elephant, we have 5G, we have the cloud, we have the Internet of Things, we have wearables, we have augmented reality. And, what I'm describing here isn't sort of just a nerdy observation. I think it's more fundamental than that. The world is literally becoming a giant computer. And I think it's necessary to have a step like that in between. Like, one of the reasons we've had so much trouble bringing consumer-facing IoT devices to market, and the reason why these companies have struggled with that, with home automation and so on, is precisely because they don't have this world computer with a nice operating system in between to make that easy and to make that possible. And, to try to get your phone to control all the devices around your house is kind of like on a desktop computer to try to plugging a mouse and a keyboard directly into your scanner. It just doesn't work that way. You need a computer in between that. And so again, I'd like to propose that the next major platform shift here, the next major revolution, will be the world computer. And you always have to be careful when you're saying that this is going to be the last platform shift, because who knows what's going to come next. But again, it's hard to imagine what could be bigger or more powerful than this. And of course, there will always be better upgrades. We're going to replace our data centers with quantum computing data centers, and we'll have brain-computer interfaces that will be invented. But as a fundamental paradigm, once you've got this world computer with an operating system at that level, then that's a pretty powerful next step that will enable all of these spatial compute technologies. Okay. Yeah, I'd welcome any questions now.
Thank you, Alex. Now it's all clear to me and I can finally retire.
Yeah, thank you. And thanks to everyone for listening.
Yeah. We have time for one question, and I'm shooting basically to ask you to elaborate a little bit on the world computer operating system development, as that is the key part, at least to me. Yeah, so where are we? Where are you with your company?
Yeah, and so that's the piece that's been missing. So the heart, and this is sort of always the story of technology, is hardware is often ahead of software. And so no one has really ever built a proper operating system to manage the world computer. And there have been bits and pieces built. So, like the company like Uber or Shazam, they were able to take advantage of this hardware and connect your phone and your sensors to a server to make interesting things happen and to build a successful business around that. But to build truly a grandiose and sort of global, this sort of get to the next level of development, we need something more, right? So far, it's almost like we've had this sort of very, very basic, it's like we've been programming an assembly code on the world computer. And what we need is the proper operating system and the proper development tools. And so that's what my company Xperiel has been working on, exactly that, is that it is fundamentally different than a computer in certain ways, right? And to have not all the pieces aren't sitting on your desktop, and there are latency issues, and there are development issues in terms of all these different modalities, like especially with the Internet of Things, there are 1,000 different devices out there that are all connected to the Internet of Things, and no two of them are compatible. And that's a real problem, right? Because if you want to write some software that makes them compatible, you're going to have to spend a huge amount of money to do that. So what you really need is an operating system and a development tool intermediating that, so a layer on top of that, so that everyone doesn't have to constantly reinvent the wheel and climb the mountain from sea level. You want to give them the operating system that gets them all the way up to near the peak, so they just have to do the final step and work in the business logic rather than have to build the whole stack below them. And so that's what my company Xperiel has been working on, is building the operating system for this world computer, as well as the development tools. And for the development tools, we want them to be as democratic as possible, right? We want to have the broadest applicability. So it's not just software engineers that have access to these tools, but really everybody. So our real goal here has been one of democratization, is that with this very powerful new paradigm of the world computer coming, we want everyone to be able to participate in that and get the high-paying Silicon Valley tech jobs.
That sounds like an excellent direction to go forward with, and should be also getting tons of venture capital to support you in case you need any.
Right.
But
right.
Yeah. But at this point of time, we need to basically put an end to the online session at this point of time. Anyone interested on asking more questions to Alex, just use the chat box on the side of the video stream, and then we'll get them answered. So thank you, Alex.
All right, thank you for having me.
Remember,